In this video, we are going to prove the quotient rule. Now, the quotient rule states that if h of x is equal to the quotient f of x over g of x, then h prime of x is equal to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared, so long as the denominator doesn't equal 0. There's also a Leibniz notation for it. For this proof, we'll focus on the Newton notation for that quotient rule. So how do we prove such a thing? Well, let's start with h of x equaling f of x over g of x. Okay? So we're going to begin with that. Now we're going to multiply both sides by g of x, and so that has the effect of saying h of x times g of x equals f of x. Okay, so we're multiplying both sides by g of x. It sort of comes up, so to speak, on the left-hand side. Now, what we're going to do next is we're going to differentiate both sides. And fortunately, we've already proven the product rule. So we know the derivative of this product. It's just h prime of x g of x plus h of x g prime of x right here. And then when we differentiate the right-hand side, we simply get f prime of x. So we're up to here so far. What we're then going to do, we're going to subtract h of x g prime of x from both sides. In slang, some people would say we're going to bring that over to that side. And so what we get, as you see up at the top of the next page, is h prime of x times g of x equals f prime of x minus h of x g prime of x. Now, let's divide both sides by g of x. The impact of that on the left is fairly straightforward. If we divide that side by g of x, it's gone. We're going to divide the other side by g of x as well. And so we end up with a line that looks like that. The next thing we're going to do is right here where we have h of x, we're going to sub back in f of x over g of x. That's literally written right in the question. So we're going to sub that back in the next line. And that's what we've got here. Okay? Now, we've got essentially a fraction with a numerator and a denominator. Let's multiply both of those by g of x. If we do that, the denominator becomes g of x quantity squared. Fairly straightforwardly, g of x times g of x would be g of x quantity squared. Now, g of x times this numerator would simply have the effect of distributing g of x right there. So it becomes f prime of x g of x. And then also multiplying g of x times this whole term. Well, that whole term has a g of x in the denominator, so they end up crossing out. And so amazingly, what we have, before showing that step of it crossing out, we end up with this expression here. The numerator contains factors of f of x, g prime of x, and g of x. The denominator contains a factor of g of x. So clearly we can cross these guys out. And what we're left with is exactly what we were asked to prove. We're left with h prime of x equaling f prime of x g of x minus f of x g prime of x all over g of x quantity squared.